Will the laws of physics change? The laws of physics have the same form in all frames of reference. This is what we call the principle of relativity. The principle of relativity states that there is no such thing as an absolute frame of reference, i.e. the laws of physics established in a frame of reference. After the appropriate coordinate transformation, it can be applied to any other reference system. This principle was first proposed by Galileo. At the beginning of classical physics, there was a heated debate. Proponents of the Copernican doctrine believed that the Earth was moving, that is, the theory of Earth motion. Defending Aristotle and Ptolemy, the people of the system think that the Earth is stationary, that is, the Earth is still. At that time, proponents of the Daijing theory proposed an excellent argument against the theory of Earth movement. That is, if the Earth is moving at a high speed, why can't we feel it at all when we are on the Earth? In response to this question, Galileo's work published in 1632 in Dialogues on the Two World Systems of Ptolemy and Copernicus. The answer was given thoroughly. At that time, he used the example of a large ship called Salvatai. The principle of relativity is proposed. The state of this large ship is stationary or moving at a constant speed. In his book, Galileo describes such a survival scenario. You and some friends are trapped in the main cabin below the deck of a large ship. There were a few fish in the bowl and a water bottle hanging from the roof of the cabin. Water droplets drip into a wide-mouthed jar below. When the boat is stationary, you look closely and you see flies in the same way. Speed in all directions in the cabin. The fish swim haphazardly in the bowl, and the droplets drip into the jar below. You raise your hand and throw something at a friend, as long as the distance is the same. The force used to throw is the same in any direction. At this point, you jump with both feet, no matter which direction you are jumping. The distance from the place is equal. Now that all of this is known, let the boat move at a constant speed. And the boat doesn't shake from side to side. At this time, observe the above phenomenon again. What happens when you do this? The conclusion is that nothing has changed in the slightest. Determines whether the ship is in motion or stationary. An example of the large ship, Salvatai. It illustrates a very important truth, i.e. any kind of phenomenon that you can't happen from the boat. Determine what kind of motion the ship is in. This conclusion is Galileo's principle of relativity. The Salvatai ship is an example of an inertial frame of reference, and moving at a uniform speed at different speeds is not. Objects that swing left and right are inertial frames of reference. Galileo thought of a phenomenon seen in an inertial frame of reference. It can also be seen in another inertial frame of reference, and it's exactly the same. Of course, Galileo's principle of relativity is applicable in the field of mechanics. And Einstein then extended it to the entire field of physics, including electromagnetism. The principle of special relativity is proposed, i.e. the laws of physics in any inertia. They all have the same form in the frame of reference. However, due to the principle of special relativity, non-inertial frames of reference are not included. So Einstein then relativized it. The principle is further extended to all reference frames. That is, the laws of physics have the same form in all frames of reference. So far, we know, the laws of physics are far from changing, no matter when and where.